Hello everybody, my name is Dovydas and welcome to Tribe of AI Meetup, Artificial Intelligence for Everyone. So first of all, a little bit about myself. I am like the founder of Tribe of AI and also I'm a machine learning engineer at Vinted. These are mostly like the things which I do. Don't have a lot of time to do anything else. I want to thank our sponsors. They are the ones which allow us to continue working on this project. So can I get like your applause for Tech Consult? Yeah, I won't ask you to clap for everybody. So these are the guys who are helping me out to make this thing going. And today in our program we have these things. First of all, we have like usually we have like a few people who are not part of our community yet. So I'll introduce to what the Tribe of AI is all about. Also, today's presentation is 11 things that everybody must know about deep learning. And finally, the most important part is networking, where you can ask, we are a community, therefore, like communicating and networking with the community is like the most important thing which you can do. So please stay after the presentation, talk to your fellow like members of Tribe of AI, learn what we are trying to achieve, why are they here, other reasons, can you learn something from them, or maybe you can teach something to them. So first of all, the introduction. One thing which we do is, you might have noticed, we are doing meetups, the ones in which you are right now. The structure of the meetups usually is that we meet every month. We are very regular. I think we haven't skipped a month for, this is our 15th meetup, so 15 months in a row, never skipped one. Also, it's all about syncing with the community. That means you can always drop in here, like find out what's new, what's in the learning community, in the AI learning communities, like main things. At the same time, it's a platform for all the announcements. Pretty much, if we do something else, if we do something new, or if we like start workshops or like boot camps or whatever, this is the platform where this thing will be announced, and this is where you will learn about this thing. So that's meetups. Another thing which we do is a boot camp. The bootcamp has been already going on for, if I'm not mistaken, 6 months already, so it's quite matured. It's like its principles are that we are learning on site really fast, in a structured way, intensive and practically applicable way to learn deep learning and artificial intelligence. The structure of the meetup is we commit to spend 15 hours per week on learning deep learning. We meet 3 times a week. All in all, we'll have 18 sprints. As I mentioned, we are mostly like two-thirds of our way done. And we'll do a lot of projects with one final major capstone project. The last of our major products is workshops. So I know that some of you are participating in the workshops, so I'm glad to see you here. Workshops are all about helping you to become an AI expert. So pretty similar to what the bootcamp is trying to achieve, but this time it has different principles. It has a different principle that we do not create the content. There are lots of good online content which you can like use to learn, that allows us to be like super flexible and pretty much replace, if something is not relevant anymore, we can immediately replace this thing with something new. We are also trying to be very practical, therefore doesn't require you to study for 3 years like mathematics and statistics before you are allowed to attempt anything with machine learning or data science. This is not a hard requirement. It's like never hurts to know math or statistics, but at the same time, it's not a requirement. You can pick up those like missing skills as you go along, not a big deal. Also, we use agile and lean principles as much as we can for the learning process, mostly like improvising, but trying every week, trying to make our process better, trying to change the workshops with every iteration so that the content is like as up to date as possible. With like filler material, if something is like outdated, we like share this information and try to make the whole thing better for like ourselves and at the same time for the future generations. The best thing about this one is that workshops are free and anybody can register, and if you're lucky, you are like it obviously has like a limit, but if you are among the selected people, you can learn pretty much from zero to AI expert for free. The workshops are, as I said, we have different classes, therefore anybody can join, no matter what your skill level is. For the F class, we are trying to teach you Python fundamentals. E class, advanced Python, helping you to like, if you know some other programming language, or if you're like very beginner but already know the basics in Python, so you can go to the E class. If you know Python well enough, you go to D class. If you know data science, like mostly data analytics, but don't know machine learning, you can choose C class and above. So you can see what the classes are all about. The thing is that you can start at the F class and move all the way to the S class, never leaving the school of our Tribe of AI workshop system. So it's like you have an opportunity to go, as I said, from total beginner to AI, working on AI projects. The structure is not as intense as in the bootcamps. You have to commit for at least 8 hours per week, preferably a little bit more. We meet every Saturday. The thing about workshops with specific sauce is that you learn at home, you watch videos, you practice exercises at home. At the same time, during the meetings, you sync with other team members, so you're part of the team, and you sync with the team members during our weekly meetings. So if you would like to participate in our workshops, like today I'm going to announce like the registration link on Slack and also on the Facebook group. So like if you're already on Slack, you'll just get the registration link. If you are not on Slack yet, so you have to register to Slack and then follow the general channel. There all information will be posted. Finally, we're ready to move to the presentation, 11 things which everybody must know about deep learning. And before we start, I want to do a quick poll. Who here already works with deep learning? Who has created like at least one neural network, or done pip install TensorFlow or conda install TensorFlow, something like that? So not a lot of you. Who has some experience with machine learning? All right, much more. What about data science, data analytics, business intelligence, these type of things? All right, and who has like only a very vague idea what's deep learning and how this relates to everything? All right, so also not that few of you. Very good. It's going to be very educational. So first thing that you must know about deep learning, like everybody must know about deep learning, is like, did I name it? Yeah, about deep learning, not about artificial intelligence. But these things are so interchangeable these days that sometimes I even get confused myself. So first thing is deep learning is a subfield of artificial intelligence. Actually, it's not only a subfield, it is a subfield. That means that artificial intelligence is this big old I don't know, field. Then machine learning is much smaller, like deals with more specific problems, especially with like algorithms which can learn from data. And deep learning is only that subset of machine learning, which is already a subset of artificial intelligence, which has algorithms that learn from data, but specifically using deep artificial neural networks. So that's the whole deal. Artificial intelligence, anything that can show intelligent behavior. For example, do you know about Gary Kasparov's match with Deep Blue? It's the old one, like I don't even remember, but it's more than 10 years old. So no machine learning happened during this match. Machine was pretty much like built, and then it played the game. Thus it didn't improve itself during the game, did not improve itself. Pretty much how it was programmed, it stayed that way. No really capacity for learning. On the other hand, if you take a more recent match, AlphaGo with Leos Dung, this match was very different because AlphaGo, the algorithm behind the, like, do you know about this match, AlphaGo versus Leos Dung? Like, the Go is a much more difficult game for computers to learn than chess. Therefore, it was expected that people will not build such algorithms which can challenge the Go grandmasters for quite some time. It was estimated like from 5 to 15 years, but after the estimations were kind of like the ink was still drying, it was like the AlphaGo beat the top human player, and right now it's not even a competition. Right now these systems are way beyond, like it's not way beyond, but it's quite beyond what humans can possibly achieve. So these systems actually use machine learning. It didn't use that during the match, but these systems like trained, like they're very different versions of AlphaGo, but AlphaGo 0, like a more advanced version, for example, it had no prior knowledge of like humans. It only played against itself, and it learned that way by playing against itself. That's how this algorithm improved. So thanks to machine learning, we have a different breed of artificial intelligence. We have machines that are not only intelligent, but that can learn that like the more experience it gathers, the better it gets in certain kinds of problem. Yes?
Sir, is it allowed to ask questions?
Yeah, sure, go ahead. Like, there are not that many of you, so you are allowed to ask questions.
Could you please one more time say the difference between machine learning and deep learning?
Sure. So maybe we have somebody from the audience who can answer this question. Be brave. Yeah, let's do this more. I kept saying that let's make this more of a discussion rather than presentation. But this is pretty much like passively listening, not interesting. You're not learning a lot by just passively absorbing information. Maybe somebody from the audience would like to be brave and try your shot, give your best shot at what the question was. What's the difference between deep learning and machine learning? Right, I'll start. So the difference is that machine learning encompasses all the methods for machines, like models that learn from data. Deep learning only deals with artificial neural networks, and more specifically deep artificial neural networks. That has deep meaning having one or more hidden layers. We are going to talk a little bit about what's the hidden layer, but pretty much it's we're gonna talk about it. But artificial deep neural networks, meaning having more than one hidden layer. The second thing which you must know about deep learning is that it finally allows us to extract information from unstructured data. Previously, we only could deal with information that was stored nicely in databases, and more specifically in database tables. Now we can extract information from many more sources. So does anybody know the difference between structured and unstructured data? Yes, go ahead.
I'll take a stab at it.
Yeah, sure.
So structured data would be something that is organized in some way, and unstructured data has little or no organization.
That's a very reasonable way to describe it. Unfortunately, it's not correct. The naming of these things is pretty insane. Like, in my honest opinion, the fact that if you remember the circle in the last slide, the deep learning and machine learning and artificial intelligence, in the media currently pretty much everything what's being called artificial intelligence is actually deep learning. Somehow, like, deep artificial intelligence being this more marketing-y term says that everything is artificial intelligence, and they stamp Terminator and human brains on pretty much every article. So same like naming misfortune happened here. So structured data, you are right about this part. Structured data is the data which is structured, more specifically structured in columns and rows. So if you ever worked with Excel, you have worked with structured data. If you ever worked with a database, SQL, that's a good example of structured data. What about unstructured data then?
Can I take another stab at it?
All right, sure.
So unstructured data would be something like in nodes that is not in rows but in more of nodes.
Like a graph, right?
Kind of like a graph, yeah.
All right, that's a good second guess. Unfortunately, it's also incorrect. So
it can be some stream of data, speech.
All right.
Text.
Yeah, so that's exactly what it is. Unstructured data is images, videos, sequences like natural language text, even like information generated from games. But what most of that information, what it all has in common is that it is probably more structured. Images have to be encoded in a very specific way. Natural language text is encoded also in a very specific way. So this information is, I would argue that in like most cases, is more structured than the structured information, because it has to be very specifically encoded. Therefore, like, this distinction doesn't really, I don't agree very much with this naming, but the fact that we can use deep learning to extract information from videos. We can use deep learning to get information from images, from audio files, from like messages, from comments, from everywhere, where previously it was either in a table or it was unavailable. So that's the, like, it might look like that deep learning is just artificial neural networks. Maybe that's, like faster or like better somehow, but it unlocks a different kind of like qualitative qualitative analysis. Suddenly we can understand who is in the picture. Suddenly you can make like iPhones to unlock with just seeing your face, and it doesn't get triggered by masks, by you sleeping, or by, you know, like the person who looks very, very similar to you. It works only on you. So these technologies are only available because we have deep learning. By the way, I encourage you to ask questions. Don't, like, this is more fun for me if I can make more specific examples. Yeah, sure.
So I understand with the face recognition, what's an example of, and I understand with voice, what's an example of video? Like what would be an example of that? Okay,
so video examples, like classical video example is sport. There you can, for example, there is a basketball match, and you can identify various basketball combinations, like is it dribbling, is it like passing, is it scoring. So these require video information. It's not enough, you know, to have a still shot of like a person doing that, because you have no idea what did he just throw the ball, or is he like preparing to receive the ball. But this video sequence, like classifying, even like granularly classifying what person achieved something in this video, it's even this thing is available. Like you identify a person and you identify an action for that person. There are like more examples. Video, by the way, is not that popular because it requires a ton of computing power. Even images require quite a bit of computing power, but video is like much more demanding, and therefore there are not that many. Like in images have tons of applications. Videos also have tons of applications, but it probably will take a couple of years until we see everything, you know, flourish, and like people finally create applications like apps which you can download or enhance your products with the new deep learning solutions. Because video is like, it's a very, very new field, and video is the frontier of this new field. There are also like more examples which came to my head are pose estimation, somehow like twitchy. So pose estimation, for example, you're exercising and they kind of see your pose. Are you doing the exercise correctly, or are you not doing this exercise? Like maybe you're like that and you're doing squats. So you're going to hurt yourself, and your phone can say, oh, look, you are doing this whole thing wrong, like stop immediately because you're going to hurt yourself. It's your like trainer, but you cannot get this information from a still picture because you have to see the whole motion. Are you doing this correctly or not? Still pictures are not enough for that. Yeah, so let's move to the third thing which you must know about deep learning. Is deep learning can approximate any continuous function. By the way, I always thought that it's deep learning can approximate any geometric function. I kind of updated my knowledge today. So deep learning, what does that mean? First of all, it means that the function in this case means that you give your model some kind of input, for example, an image, which is just a tensor of numbers. Because an image, like, imagine what an image is, right? A digital image. It's like number of rows, number like a height, a width, number of rows, number of columns, right? And 3 dimensions, red, green, and blue. This thing is like a multi-dimensional array of numbers, which can also be called, like, and which we call in the like machine learning community a tensor. But the tensor pretty much is the same thing as multi-dimensional array. So we take this tensor as an input, as you learned, you know, fx at school. that x being the only input. So instead of one input, we have like 1,000,000 inputs. But that's the same deal. There's still f, a function which transforms these numbers into some kind of answer. The same rules apply in deep learning or artificial neural networks with at least one hidden layer can approximate any of those functions. That's, by the way, called universal approximation theorem, and this is kind of proved by mathematics. It doesn't, by the way, doesn't say about learning the parameters of these functions. It just says that it can be approximated, so it's not that easy, but at least the potential is immense. Yes, we have a question.
A more basic example, something like time series, we can consider it if it's rapidly made the time series that it's a continuous function, right? So how would it approximate such functions?
How it approximate a function that continues like with the time series input?
For example, I put a temperature meter outside, and it takes a sample of the temperature every second. That's pretty much a continuous function, right?
Mm-hmm.
So
that's a continuous data. It's like there is a bit of a difference between like.
You say that there's a, well, if it's inside and there's an air conditioner, could be a function because the air conditioner has some type of processor that governs it. So approximating this data can you just plug in data and it gives you like a function of the data if we approximate. Can it make sense? Or
I think this we might need to discuss this one like during the networking part, because I'm not cannot yet imagine like this concrete example. But let's talk after the presentation. I'm sure that it can do that. Like you can extract from like these continuous continuous as in each of the data point is a continuous number, but at the same time it's called sequential data, where all of the data points go in sequence. They depend on the previous value. So deep neural networks can work with both of these, and like we'll see some examples with natural language processing. There are like pretty much words are also a sequence of numbers, so it works with words, and it can definitely work with any sequential data. So let's move to the fourth point. Deep learning models are not black boxes. You might have heard that deep learning is very much black boxes. We do not know why the model decided to do something, and it's impossible to know. It gives us, this sense of mystery that the model just made the decision. The humans, they're not like responsible. They just gave the data to the model said it must be that, and that's what we are told. Actually, if you work in deep learning, you know that we have like quite a few of these diagnostic tools. They're different than in classical machine learning. In classical machine learning, we didn't have to do pretty much anything. It was like built in. The diagnostics were all around us, all built in. In deep learning, what do you know? We have to work a little bit for it, but we still can diagnose the deep neural networks. Some people have made pretty awesome diagnostic tools. I have to refresh it because it seemed to be a bit buggy, but yeah, I think it will work. So give me a number from 0 to 9.
1.
1. Let me try to draw 1 as best as I can. So this is what the deep neural network sees. Let me zoom in that a little bit. I guess this is canvas, so you have to have very, very good eyes to see that the correct answer is 1 in the very, very top of the screen. So this is how the neural network creates these feature maps. The intermediate layers, which you are seeing right here, are called feature maps. You can see the whole path where your input is getting to various feature maps, finally getting to the answer, and getting the first guess of being 1. Let's try something else. Let's try some difficult number like 2. Yeah, my drawing skills are not amazing. Yeah, what you see, the neural network is very, very confident in the top. In the top, you see that number 2 is very, very highlighted, and nothing else is highlighted. So its first guess is that it's 2. Let's give it something more difficult. Let's make it 3, but yeah, like that. I'm not sure. I didn't even know what I was trying to draw, but it seems pretty sure that it's 2, but it also can be 7, 6, or even 8. The neural network is not much less sure. The second guess is 6, first guess is 2, but I'm not making this easy, right? I didn't even know like the number which I was trying to draw. You can disable, no, it doesn't help. I thought maybe it will zoom in a little bit if I disable some layers, but never mind. So this is just an example. One specific instance of like how you can diagnose what your neural network is doing. You can visualize these feature maps. You see they are getting smaller and smaller and smaller, and in the end we end up with one number for each class which we are trying to predict. This is not the only visualization tool available. There is another one, like there are actually like a lot of those, but there is another one which will help us with words. So give me some word now. Word is a very good example of a word, but it won't tell us like a lot. A word like a cat, a dog, a house, a car. Very wise choice. So we can search for everything that has a car in it. Let me choose. Yeah, I think this is cars. I have to be very, very specific on clicking, because this one depends on the accurateness of your clicks. Let me zoom that in a little bit. So nearest point of the original space of cars actually, because I clicked on cars, is vehicles, then cars, then automobiles, trucks, trains, racing, motorcycles, vehicle, engines, and so on. These are word embeddings from a language model. This specific language model is called Word2Vec, and it learned, it was trained on like huge data sets, and it learned which words are close to each other and which words are farther away. So I can select the 100 actually most similar words by just searching for that. Let's give it something else. Recognition. I don't think it even learned this word. You have to be, so the thing about this Word2Vec model, it is limited to the 10,000 most popular words. So you don't get like infinite, but we can have recognizable or recognize. Let's choose recognize. Nearest words are accept, acknowledge, recognized, recognizes, believes, applies, considers, and so on. So pretty close in this dimension. So you can see it's again a different example, not computer vision example, but a natural language processing example of how we can understand what this model actually learned. It is not as straightforward, right? People tried hard to make this visualization tool, that's true. They made it quite good, quite universal, which like allows everybody to use it. But these tools can be reused for your neural network model, and you're not allowed to anytime to say that my neural network is a black box model and I have no idea how it works, but I trust that it works alright. So you should be trying to find a ways to understand how your model makes something, makes predictions or what it learned. Let's move on. The final example is what's called like computer vision heat maps. So you have a heat map of your activations pretty much on the final feature map. If you remember feature map from the previous example, you see some parts like lighting up. So we take these lighting up areas and we put it on top of this original image, and we know that this dog was classified as this particular species because of this area. The model didn't care about anything on the grass, the model didn't care about the legs or the body of the dog. It concentrated on the face of the dog, and this is how it decided what like type of dog it is, what breed of dog it is. So neural networks are not black box, and hopefully you already see the benefit in using deep learning. So how can you do that? There are two main deep learning frameworks, currently most popular ones. It's Tensorflow and PyTorch. Actually, last year, when I was doing a presentation about the most popular deep learning models, I had 4 of those. I had deep learning frameworks, I had 4 of those. I had TensorFlow, PyTorch, Keras, and FastAI. Everybody pretty much used Keras, the TensorFlow backend, so they were very, very related. What happened this year is TensorFlow ate Keras. It integrated Keras into its main, Keras pretty much became just a module of TensorFlow, an API which is recommended for everybody to use. Also, you changed the logo, so a lot happened. PyTorch didn't make any radical changes. It was pretty popular, it increased in popularity, it had quite a winning formula, it was quite easy to learn, more intuitive than TensorFlow, especially if you use TensorFlow without Keras. So this year, PyTorch is continuing to reap the benefit, the fruits of its clever architecture. So these two things are the most popular, and if you want to learn how to do neural networks, you should pretty much use one or the other. The sixth thing that you must know about deep learning is it was inspired by the human brains, but doesn't have that much in common anymore. So when we see artificial intelligence, usually we see a picture like that, like a picture of brains and like information going in and then becoming like digital. Or sometimes if you're watching a tutorial about deep learning, you're even shown this picture, and I had to memorize at some point what are axons, what are dendrites, and things like that. Unfortunately, this is like saying that these models have multiple inputs and a single output. Like each neuron has multiple inputs and a singular output, doesn't really distinguish that much from a lot of other things, doesn't really make it very much brainy. Currently, this is more accurate representation of neural networks than the neuron. Maybe somebody knows why.
many layers?
Yes. Very good. Both of these have many layers. The layers is what deep learning is all about these days. It's not about individual neurons, because we have like millions of those, hundreds of millions most often. So we have hundreds of millions of neurons, and like understanding a single neuron that it has like pretty much how many things can have multiple inputs and singular output? Lots of them. Like in mathematics in the 5th grade, we learned a function which had like x and y, and we got one result, something like 0. So it isn't very neurony, doesn't require you to be a neuron, but the actual, the fun part is that these layers magically stacked on top of one another make this whole thing work. And most of our neural networks look exactly like that, actually even taller. Do you know like what large, like deep, actually deep neural network architectures, how many layers do they have? Give it a guess, obviously, if you don't know.
Millions?
Not millions, actually. I was overhyping it, I guess. Not millions, fewer. Not thousands, but close to. Yes?
2.
More than 2. So a little bit less than 1,000 are the currently deepest architectures. I think NASNet is one of the deepest architectures which we currently have. It has, if I remember correctly, 600 something layers. Yes.
But what is actually a layer? What is it?
So what is a layer? Very good question. So if you have, on one hand you have this neuron, right? Imagine having 100 of these neurons. Can you do that?
Yeah.
Have you imagined that already? So having 100 of neurons means having 100 of outputs, right? Because one neuron, one output. This is the output. Like this tail means that it has one output. These multiple, like dendrites, mean that it can have as many inputs as needed. Doesn't care about number of inputs, just one output. So 100 and like a layer with 100 neurons will have 100 outputs. The next layer can have yet again as many neurons as you want, because we are densely connected. That means that every single of these neurons will connect, will output its result to every single of the next layer's neurons. So it's very densely connected. It has like the number of connections where you just multiply these two numbers. Like if you have 100 of the first layer, 100 neurons in the first layer and 100 in the next layer, just multiply those together, add 1 for the bias, and you know how many parameters you have. So a neuron is just a bunch of these, a layer is just a bunch of these neurons. Next layer is another bunch of these neurons. Next layer, yet more neurons, and so on and so on. Of course, as I said, like I don't have a better picture, so I wouldn't even want to use this neuron, because it just means having many inputs and one output. That's what a layer is. Of course, you will learn, like if you let's not talk mathy stuff today. It's not required. But when you are learning about, or when you're using and creating your neural networks, you will learn about the shapes. The shapes are most important thing. There are how many inputs you will have, how many outputs. So that's usually the case of what we have to learn. If you understand that, if you remember your 6th grade mathematics at school, it's pretty much enough to understand how one neuron works. then you have to, like, in your head, multiply this 1 by 20 or several hundred millions. Have a question?
Can you go back to number 6 for a second?
This one?
Because you said here that it's inspired by the human brain, but don't have a lot in common. But just now you said that each layer is like neurons, so...
It's called neuron, yes. But like what I want to point out, I kind of guess my message is being a little bit lost here, so I don't have a better visualization. This neuron can be anything else. It can be a chair. I can make the same argument with saying, oh, look, my chair can have 3 legs or 4 legs, and only one person can sit on the chair. So it supports the ground on 3 layers and on 3 inputs and has just 1 output. It's just an analogy that everybody keeps coming up with. Doesn't require to know anything about real brain. Pretty much just to sound fancy, I guess we still are using these like neurons. Also, they are called for historical reasons, neural networks and neurons and whatever. So that's the main reason why this picture is being shown all the time. So what I'm saying is, you don't have to know anything about this picture. It's not required. Seventh thing, you probably have heard that deep learning is really cool, but it only works if you have a lot of data. So I'm claiming that it's not necessarily the case. You might be pointing to me this graph, like, look, deep learning really shines if you have a lot of data. And this is, by the way, from Andrew and G, one of the best courses on deep learning. It's like deep learning specialization on Coursera. And this is the chart which shows that older algorithms had this gap. They didn't scale that well. I mean, you get more data, they didn't get better neural networks, more data, more performance. They have a lot of neurons, and therefore we have like enormous capacity for learning. You might be saying, so look, that proves that you must have a lot of data for deep learning to work. But what people don't, like, kind of, I don't know, don't see in this picture, or don't like to see in this picture, that this pretty much works the same. If you don't have a lot of data, still works as state of the art. And even if we consider the more modern like developments in deep learning, because deep learning is the hot field right now, it keeps getting better pretty much every month. So with new developments, even if 2 years ago this was the case, maybe right now this is no longer the case. Maybe deep learning is best at everything, even if you don't have a lot of data. So I know, like, I know anecdotal evidence of people training neural networks on tens of images. I myself have trained neural networks which has like fewer than 100 images per class. Still works. If your task is not very difficult, of course, if you have to like distinguish the breeds of the dogs, which like tend to be like very similar, very hard for a computer to understand, you're not getting state-of-the-art results. But if you're doing something simpler, like how many chairs you have in this picture, or do you have like at least one human in this picture, if you're doing these types of problems, even a few data samples is enough to train pretty good deep learning model. The next one is very interesting. You don't need PhD in math to understand neural networks. This is, again, one of the misconceptions, that this is very math heavy. That to build a neural network, you are pretty much solving some kind of master equations for a month and then coding for 5 minutes and you get a neural network. So this maybe is somewhat true if you're doing deep learning research. Maybe you kind of benefit more from having strong mathematical background, but most of the people are not in this, like most of the people are not doing research. At the same time as most of the programmers are not building their operating systems or creating their programming languages, most of people who work with deep learning are actually creating models using TensorFlow, using pre-built tools that pre-built architectures, just figuring out the best way to solve this problem and applying your knowledge to build the model. So you don't do that much math. Actually, in some cases, you don't do any math. Then therefore, you don't need a PhD in math. To learn how it works, it's beneficial to have like university level, like not necessarily like math course. If you had done like anything like physics, statistics, economics, you probably got like one mathematics course in the university. Usually that's enough to understand pretty much everything what's going on with deep learning, with some kind of like refreshers. I'm also I'm giving you for free this super amazing deep learning simplifier, which if you ever been told that this is a rectified linear unit, and I have applied rectified linear unit on top of my neural network as an activation function, just means that I have done this max XOR 0, pretty much replaced all the negative values with zeros. That's rectified linear unit. Back propagation, so if you have done university level mathematics, you have done chain rule, you have tried chain rule. So back propagation pretty much almost exactly means applying the chain rule. It has some like a bit different connotation, but more or less same thing. Forward pass is just a bunch of matrix multiplications. Pretty much matrix multiplications, then replace all the negatives with zeros. Matrix multiplication, replace all the negatives with zeros, you get pretty good deep learning model. So some things sound different, and because we sound different, we sound more difficult. And therefore, deep learning might seem like, oh, that's a big deal, I have to learn a lot. But you have to just know some shortcuts. You have to, of course, learn some new things, but still, it's not, like sometimes it sounds more difficult than it actually is. If you want to see deep learning in action, there is an amazing website called playgroundtensorflow.org, pretty much this one. I have already opened it. So here, you, in a very, very visual way, you can see how deep learning works. I'll just zoom it a little bit more. So this is quite a hard problem, right? You have to identify the middle green, the middle blue dots from the outer orange dots. They are not like very, very they're a little bit scattered. And if you click right here, you can see how your deep learning model trains and how it comes up with a solution. So pretty much already trained, and this is the decision boundary which it found. You can even increase your noisiness of your data. You can have you can give your neural network really hard time. Maybe that's a little bit too much, but this one is super difficult, right? A lot of green, a lot of orange dots in the middle. Even with that, your neural network will find a solution. So even noisy data is not that difficult for deep learning models. Of course, it depends on the problem, and you see it's not that perfect circle anymore if we have noisy data, but you can, in a very, very visual way, see what the hidden layers do. If I don't have any hidden layers, it won't learn. It's pretty much impossible to learn this thing with just a linear function. If I have a hidden layer, remember I can approximate anything. I just don't have enough neurons right now. So if I had more neurons, I will get an approximation. Or to be more efficient, I need more. I think that would be enough. I can be more efficient and have more layers, because more layers allow me to have like these higher level, more sequential, more steps applied to my input data to get to the output result. By the way, this thing works on your computer, so I will not try to kill my computer right now playing too much with it, but remember that you can learn and actually try various different neural network architectures on your own, on your machine, pretty fast on these super simple problems without having any background, without having to install anything or something like that. One of the most important things in practice is using pre-trained models. You might be thinking, so okay, what are pre-trained models? In the industry, we have some kind of, we have some benchmarks, pretty much problems on which everybody competes to find the best solution. And by everybody, I mean like companies like Microsoft, Facebook, Google, Amazon. They all provide their solutions in these yearly or like competitions, or some competitions are even like ongoing. And they publish their results with new developments which help the deep learning community. And after these models are trained, they do not throw them away. They kind of store them and say, okay, so if we spend like $5,000 on like our cloud to train this model, but you can get the weights for free. They're on our GitHub. So what you can do is you can download these weights, put on your own outputs, like let's say they're trained on 1,000 classes, that's called the ImageNet. So 1,000 different classes of objects in an image, but you want to use it for, I don't know, hot dog or not hot dog example. So you take this huge pre-trained neural network, put on 2 neurons at the end, so for 2 classes, and you train your model like only for a fraction of the epochs with a fraction of the cost, and you get state-of-the-art results. So this is the magic of pre-training, and this is like initially it was only done with computer vision, but right now it's also being done natural language processing, as I've shown you previously with word embeddings. So there are neural networks which already learned languages, which understand which words are similar, which words have what meanings. You can have even these words like in different sizes. If you want to deploy it on mobile device, maybe you don't need all the subtle connotations for each word. Maybe it's enough to know is it like positive or negative, or like not that fine-grained word like specialization. So there are like different types of these like pre-trained word embeddings. You can get them in one of these sources. If you're using TensorFlow Hub is pretty hard to beat. It has a lot of pre-trained models. TensorFlow itself has a lot of pre-trained architectures built in without you having to use anything. You just get them, you just import these architectures from Keras applications, and you get them for free automatically, like works out of the box. For PyTorch, we have like amazing, this Hugging Face transformers that works with both TensorFlow and PyTorch, the pre-trained models.pytorch, an amazing computer vision pre-trained model collection. And the other ones like various models or model zoos, I included Onyx twice. I like it so much, so I included it twice. Now, so these sources This is where you can get the pre-trained models, and don't even think about doing actual production level work without pre-trained architecture, without pre-trained weights. You will get massively better results with a fraction of the training time. So we are closing to the end. The 10th computer vision, the 10th deep learning fact is that it's really good at natural language processing and computer vision. So you might have heard about convolutional neural networks. We have heard about convolutional neural networks, right? A few people. So convolutional neural networks really shines for computer vision. Actually can be used for sequences, so for both natural language text, but for other types of sequences. Usually, on the other hand, we think about sequences in NLP in regards of recurrent neural networks, but these recently, like in the last year, the transformer architecture, which is neither recurrent nor convolutional, just transformer, multi-head attention. So this new developments really overtook the natural language processing wars, and all the new natural language processing architectures are using these transformers in one way or another. The most famous, which you might have heard, is BERT, which if I'm not mistaken, means bidirectional embeddings from transformer. It maybe wanted to come up with these fun-sounding names by any means necessary, even if they are not super meaningful. But it's transformer-based architecture, super powerful, super huge, but at the same time allows us to really pushes the boundaries which we thought they're really hard to reach for computers to understand, like language. Right now we are much closer for computers to understand what each word means in a sentence, not only as a standalone but in a sentence. That means if you have the Queen of England and the Queen Bee, it's the Queen is a totally different word in each of the cases. So it has an understanding of a sentence level context. Finally, hopefully you are by now interested in deep learning, knowing these 10 facts. So the 11th fact, the bonus fact, is how to learn deep learning. By far the best book right now is Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow. Second edition, it's very, very different from the first edition, which was amazing for the machine learning part, but the deep learning is already outdated. The second edition, super recent, and has one of the most up-to-date knowledge on the deep learning part of the deep learning models. There's also an amazing deep learning in Python by the author of the Keras framework, which I've shown you recently. By the way, he joined TensorFlow team, so he works in Google full-time now. Also, there is Deep Learning Cookbook. That's a very nice book, which shows you different examples where you can use deep learning models in various applications. Finally, there are online courses. We have deeplearning.ai, already mentioned, from Andrew and G. We have FastAI, already mentioned their framework. They also have a course, not only a framework, but also a course. Both of them are known as FastAI. To confuse things a little bit more, they also have a company called FastAI and a website called FastAI. So a lot of FastAI stuff. All of that is amazing. One of the best courses on deep learning, giving the kind of knowledge which you couldn't find in other resources. Very hands-on, very practical. And Jeremy, the main instructor and the main author of FastAI, is himself a very successful Kaggle competitor, actually a director of Kaggle for some time now, like pursuing this, now being a lecturer at San Francisco University, and this author of FastAI course. And finally, Udacity nanodegrees. Udacity at some point really wanted to get into this deep learning space, and they can't say that rebranded, but they shifted their content very heavily towards deep learning, and they have like quite good deep learning courses right now. Finally, if you're looking for a full curriculum, obviously Tribe of AI has one, and you can follow like this curated list of things that you have to learn to become good at deep learning. Now it's time for your questions and my answers.
You mentioned that
yes.
The TensorFlow and the others are basically using Python as a background language. Is that correct?
Yes, I didn't mention that specifically, but you're right.
So the question is, what about the performance? Because Python is not the most performant language. So is that influencing the timing you need to spend training models?
Very good question. So Python, if you are not there with this fact, is one of the slowest languages there are. Like this deep learning is one of the most computationally expensive tasks which we can do. So very, very bad match. At least that looks on paper. In reality, Python, you can view Python as mostly glue code or as instructions for some kind of lower level framework actions. That, for example, everything that you do with like neural networks, most of these things actually happen on GPU using the CUDA computing engine. So your Python code pretty much means that you are telling the TensorFlow how to create this graph, which is then ran on your GPU. So actually, how long the Python code runs doesn't really affect the end result. Or that was the case until very, very recently. We are getting so good at this like lower level computing part. There actually Python kinda starts, even this like tiny fraction of the code which actually runs on Python, even that is starting to become like a little bit of a bottleneck. And there are projects such as Swift or TensorFlow to use different languages than Python for deep learning. So I personally, Python is quite a nice language. It's at the same time a little bit older language, and I would personally, yet again, prefer some kind of neural language to be used in this for this deep learning. Swift is an excellent choice in my opinion. There are like many other good new languages, but the performance is, like in my personal experience, you wouldn't get like a lot of performance boost by using a different language. You will get more convenient tooling, you will get more convenient like syntax, maybe like better like understanding. Like if you have a type language, you can understand everything, like your tools can understand everything a little bit better and get a lot other benefits, but the performance, not the first one.
Thank you.
Right. Anybody else?
So if you want to play around with this and start doing something with neural networks, do you need a machine with high-end GPU?
So you will need, you cannot do any kind of like meaningful deep learning work without a GPU, but luckily there are multiple ways how you can get GPUs for free on the cloud. Google actually provides 2 resources for free how to get free GPUs, one of them being Google Colab, like Google Colab, And the other one being Kaggle. They provide kernels with GPU support, again for free. Again, since Kaggle is owned by Google, this is Google's GPUs. I know there are like smaller players which also provide free GPUs, but personally haven't used them, so cannot say anything about them. But Kaggle and Google collab, two ways to get totally free access to the GPUs. Don't have to buy anything. Also, everything is already set up, so you don't even have to install libraries and stuff like that.
You mentioned this bootcamp that you're organizing. So it's you say you have 3 meetings during the week, right?
Yes.
So at what time do you make those meetings?
So just to clarify, bootcamp is a thing which like is happening. It's big part of Tribe of AI. Unfortunately, it's already happening, so like new people cannot join the bootcamp.
So you're going to make another one?
Yeah, eventually, yes, will be announced. Definitely, then that happens, and probably the next iteration of the bootcamp might be different from the first one. Therefore, you know, like the knowledge from the first one does not necessarily transfer to the next one. Yes.
The workshops, you said that they're from level F to level S, and you said it's once a week on Saturdays. So do you have, what level are the workshops now at?
So the workshops, like, to be clear, there are lots of classes happening simultaneously. There are 2 different concepts. There are classes for the level, and there is a team which you can think of as an instance of this class. So for example, we can have multiple level C teams, like one team which meets at 9 AM and another team that meets at 3 PM, but both of them can be at level C. So there are like multiple classes for the levels, also multiple teams for each class, which specifically have a meeting, 1-hour meeting at allocated time. So this is how it works. You have then a new time slot becomes available. I organize a new registration and decide what kind of level it's going to be, and the participants meet at that hour with me, and we talk about their learning path.
So you can start at the F level now, or it's already started?
You have to wait for a new registration, and then for the new F-class F team to be created. So you can register. Yes, you could register. After today, I'm going to announce the registration. You can register. The caveat that F-class has started quite recently, so it's probably going to be the next one will start maybe in a month or something, maybe a little bit even later. Yes.
Could you give real-world examples in Lithuania of neural networks which are implemented now, which works?
Okay, so there are companies. There are some companies which pretty much all they do is work with deep learning. Such companies as Oxipit, Neurotechnology, Xavia. That's their main business. They don't do anything else, just apply deep learning to some kind of problems. Neurotechnology is a big company, lots of projects. Oxipit is these rentgenograms, X-rays, X-rays which try to detect various diseases and X-rays. Xavia tries to build a Amazon Go type of physical store that you can just go in, take what you need, go out, and the neural networks detect your actions. That's a good application, by the way. Video data, indicates that you are taking something or putting something away, adds these things or removes these things from your basket, and allows you to have this cashier-less experience. Some companies, as Vinted and like many more, use deep learning as part of their product to make some kinds of their user experience better via these neural networks.
So I heard that Telia has launched this chatbot, right? So do you know anything about the algorithm behind it, or?
Unfortunately, I was not aware that this happened, but good for them. I'd like to see more of these applications, like applying deep learning for various tasks, for various product features. So it seems that we're all out of questions. Now it's the fun part, networking, as I mentioned. Stay along, meet new people, talk with somebody who wants also to learn deep learning or wants to, I don't know, do a project. Have fun, and see you in a month on January next year with our 16 meetups. Thank you. Viskas bus paskelbta į Facebooką ir į Meetup grupę. Okay. Tai ten bus registracija iš pradžių į Slack, turėsim užsiregistruoti į Slack ir tada jau Slack, nes labai kitaip sudėtinga komunikuoti, visi dabar Slack sueina į bendrą katilą ir tada Slack general kanale visa informacija apie workshop registracijas, na ir apie visą pagrindinį informaciją, toks pakankamai švarus kanalas ten visiems dalykams. Ačiū. Jo, dar vienas dalykas, kurį privalau padaryti, pabaigti visus streamus ir